We are on lesson 8, following a book on Precalculus by Larson. We're in the last section of chapter 1, which means we have a test coming up. We're on chapter 1, section 6, inverse functions. What you should learn. Find inverse functions informally and verify that two functions are inverse functions of each other. Use graphs of functions to decide whether functions have inverse functions. Determine whether functions are one-to-one. Find inverse functions algebraically. Okay, the graph of an inverse function. The graphs of a function f and its inverse function f inverse are related to each other in the following way. If the point AB lies in the graph of f, then the point BA must lie on the graph of f inverse and vice versa. This means that the graph of f inverse is a reflection of the graph of f in the line y equals x as shown in figure 1.39. All right, I don't know why they have to use a and b. It's just x and y. And then you flip them, and the inverse becomes yx. Okay, so if it's an inverse, what an inverse does, it flips over the line y equals x. Line y equals x. Okay, so for those on the struggle bus with what that means, it's got the slope of 1 and it's got a y-intercept of 0. So it's going through 0, 0, and then up 1 over 1. And then, so we have the original graph over on the left here of f of x is right here. And then you take all those points and you reflect it over that line, flip it over the line, mirror it across, and you get the new graph, f inverse of x, right here. Okay, so if you got the point AB on the line, you also got the point BA. So we could give those some numbers. This looks like it could be over like 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4. So this could maybe be the point 6, 4. So that means that this point here is 4, 6. Over 4, up 6. 1, 2, 3, 4, 5, 6. We'll say it's 6. All right, so just you flip the two numbers. All right, so we're going to do that on the next page on the very first one. So we got an original function f here, and we're going to write down the points for it. So this point here is over -2 and up 6. So the original f of x function, over -2 and up 6. And the next point there, down here, is at -1, 0. And then the next point over here is at 3, -2. And last of all, we got 4, -3. So the inverse of it, flipping the numbers, you just flip the x and the y. Becomes 6, -2, 0, -1, -2, 3, and flip those, -3, 4. So just you flip the x and the y all the way down. All right, and again, this is going to flip over the line y equals x. So going through 0, 0 with a slope of 1. So it's going to flip over that line. So we got 6, -2. And then 0, -1. So I'll go ahead and draw that line. I think this is the easiest piece that you can see, that this flipped over that yellow line became that piece. And it continues to connect from there. It's hard to visualize so that it reflected over the line. All right, then we got the point -2, +3. And then last of all, -3, +4. All right, so the whole point though on this, we overachieved with what we did. All they wanted us to do is say where the new points were for the inverse. Here's the original f. Where's the new points at? Well, if x is -3, the inverse for the y value, remember this means the y, that's a fancy way of saying y. The y value became 4. When it was -2, it became 3. 0, -1, and then 6, -2. So we're just filling in the inverse points. That's all you had to do. All right. To have an inverse function, a function must be 1 to 1, which means that no two elements in the domain of f correspond to the same element in the range of f. So that means, just like going back to what a function was, on a function the x's could not repeat. So each x had one y value. So you're not going to see an x more than one time, because that would mean there's like two different y values for it. To be a 1 to 1 function, the y's can't repeat. So if it's a 1 to 1 function, here it is, 1 to 1 and a function, it passes the horizontal line test to be a function, and it passes the vertical line test to be a function, and it passes the horizontal line test to be 1 to 1. So it has to do both of those things. So a function f has an inverse, f inverse of f to negative 1, if and only if f is 1 to 1. And to find that out, you can do, like I said, the horizontal line test, which we're going to look at on the next page here. This function is not 1 to 1. It is a function because it passes the vertical line test, but it's not 1 to 1 because the horizontal line test, it fails. It hits the points there twice. There are two types of graphs that always pass this test, and they have to either be always increasing or always decreasing. So an example of that would be a line. A line is always increasing or it's always decreasing. That's 1 to 1. It passes the horizontal line test and it passes the vertical line test. Another one that passes it all the time is x to the third. Y equals x to the third. It can always be increasing, or you can flip it around, then it's always decreasing. But it passes that test. All right, finding an inverse function. Use the horizontal line test to decide whether f has an inverse function. Step 2. Use the equation for f of x. Replace f of x with y. Interchange the roles of x and y and solve for y. Step 4. Replace y with f to negative 1 of x in the new equation to make it look fancy and pretty. And then last of all, you're going to verify that they're inverses, which you could do with arithmetic, or you could do it using algebra here. I want to do it the last way here. That's the way that people are going to want you to do it when you take other classes. You need to show it algebraically. All right, so the very first one down here. G of x equals x squared minus x to the fourth. It's kind of hard to read. All right, so first thing we have to do is see whether it passes the horizontal line test. So turn on your calculator, clear out what's in there. So x squared minus x to the fourth, hit graph. It makes kind of an upside down M. You can see already it fails the horizontal line test, so you're all done with it. So you can draw a little sketch of it to show that you did it. Fails horizontal line test. Because when we draw a horizontal line, it intersects it twice. So we can't, which is awesome because we're all done then. We don't have to do steps 2 through 5. We're all done. Then on the next page, the very first one, this one's easy to do. It's f of x equals 3x plus 5. Hopefully it pops right out at you that that's a line. 3x plus 5. So it's going through 5 on the y-intercept, and it's got a slope of 3. So down 3, and then right 1. So down 3, and well, no, it's positive, so it goes up 3. What am I doing? And then right 1. All right, so it's got a y-intercept of 5, and it's got a slope of 3 over 1. Okay, so there's a line, y equals 3x plus 5, and while I'm there, I'm going to sketch out the line y equals x. That's what we're going to flip over. So that's kind of where y equals x would be at. All right, so since it passes the horizontal line test, because wherever you draw a horizontal line, it's just going to intersect it once. So pass this horizontal line test. So we can continue on. So we got to switch the x and the y's now. So this is y, so it becomes x. This is the x becomes y. And then from there, we're supposed to solve it for y. So again, that's kind of steps 2 and 3. Switch the x and the y, which we just did. Now you got to solve it for y. So move the 5 over. So it'd be minus 5. Divide everybody by 3. So it gives you x over 3 minus 5/3 equals y. And then to make it look fancy, they said change the y to f to the negative 1. So f inverse of x is equal to x over 3 minus 5/3. All right, and then the last step, well, we could graph it for fun. Let's graph it. So the y-intercept here is negative 5/3, which is negative 1.6 repeating. So somewhere between negative 1 and negative 2. Then it's got a slope of 1/3, so up 1 and over 3. Oh, wow, I should really use graph paper. I'll make it my goal the next time I do graphs to use graph paper. It'd be so much prettier and look nicer. We'll put it in the calculator so you can see it, since my graph fails. Big fail. All right, so we got 3x plus 5. And then just for fun, we'll graph y equals x, and we'll make that line thicker by hitting enter in the front. And then the inverse of it is x over 3, x divided by 3, minus 5/3. All right. So there's the original one, there's y equals x, and there's the inverse right there. And we can make it even better by changing our zoom to square. That'll look perfect. All right. Last thing we have to do, we have to show that f of f inverse of x is equal to x, which is equal to f inverse of f of x. So if we do both of those and we get x, we prove that it's that they're inverses of each other. So doing the first one here, we need to pick up f inverse, put it into f. So f inverse right here, we're going to take this chunk right here and put it into the x right there. So that makes 3 times x, which is x over 3 minus 5/3, and then plus 5. So that is equal to f of f inverse of x is what I'm doing right now. So multiply across by 3. So 3 times a third is 1. And then 5/3 times 3 is just 5. So you end up with x. Then we have to do also f inverse of f. So that means that we're picking up f and putting it into f inverse. So I'm picking up f. So right here. And putting that chunk into f inverse. So putting it in here, x, becomes that. So that becomes 3x plus 5 over 3 minus then 5/3. So dividing those both by 3, we've got x plus 5/3 minus 5/3, which equals x. Therefore, f and f inverse are inverses, because we just proved it mathematically. Okay, on the next one, notice we're going to have a domain issue on it because we're taking the square root, and whenever you take the square root, you're not allowed to take the square root of a negative number, so let's talk about that right now. X minus 2 has to stay greater than or equal to 0, so x needs to be greater than or equal to 2 for the domain. All right, so if we were to graph that, the parent function is going to go right 2 because of the minus 2. And then another good point to use is 6. 6 minus 2 is 4. And then the square root of 4 is 2. Or you could put in your calculator and get those points. So we have the point 2, 0 and 6, 2. So the inverse of it would be 0, 2 and 2, 6. So there's the inverse of it. All right, so again, since this original function is 1-to-1, because it passes the vertical line test and it also passes the horizontal line test, so I guess we should write that. So step 1 passes horizontal line test. Check, done. All right, then steps 2, 3, and 4. So again, the y becomes x, the x becomes y, and then you have to solve for y. So since it's a square root, we need to square both sides. So it gives you x squared equals y minus 2. So move the minus 2 over, and it becomes plus 2. And you'll see that if we graph it, all right, let's do the graph and so we can look at it here. We got the original one here, square root of x minus 2. And then we got the line we're reflecting over, y equals x. And then last of all, we've got our inverse, which was x squared plus 2. And hopefully you can see what the issue is when we graph it. It gives you more than what you wanted. The inverse was just supposed to be the piece there on the right. We don't want the piece that I'm coming up there on the left. And the reason why that's true is because of the domain issue. We can only use numbers for x that are greater than 2. So the domain on this new one, for this new function right here, that's only true when we switch it here for x greater than 0. For x greater than or equal to 0. So the inverse of it, oh, we got to make it fancy. I didn't make it fancy. So I'm going to change that to f inverse of x is equal to x squared plus 2 for all x greater than or equal to 0. All right. Then we have to prove that it's a function. Well, not that they're functions, that they're inverses of each other. All right, so we got to do that f inverse of f. And then we have to do f of f inverse. So again, pick an f up, square root of x minus 2, putting it into the x of the inverse. So the x there is replaced by the square root of x minus 2, and then squared plus 2. Well, when you square it, it cancels out the square root, so it just becomes x minus 2, and so that's x. So hopefully the same thing will happen on the next one. So we're picking up f inverse, putting it into f. So f inverse now, pick it up, put it into that x right there. So that becomes then the square root of x, which is now x squared plus 2, and then minus 2. So you get the square root of x squared, which is just x. Therefore, f and f inverse are inverses. All right. We're going to work on reviewing for the test next. I'll see you soon.